Good afternoon, everyone. Respected chairman, co-chairman, the co-chairs, delegates from different institutes, dear students. Well, today I am going to present the small work related to portable cluster. Well known to all here. Fabrication and evaluation of battery operated manual drone cluster. Myself, Dr. Varun History from CAT Java, at the engineering department. Next, please. As I highlighted, already glass actually is unmarketed basically plants. We can say glass is growing everywhere, urban environments, agriculture waste, natural. It needs a lot of human efforts. So there is need to mechanize this. Yeah, you develop some machine which can do such type of work. So landscape and education management are essential aspects. So landscaping and management are essential aspects. This is especially outdoor spaces and urban environment agriculture. Traditionally, powered gasoline engine cluster are available. Now we have designed and fabricated the battery operated cluster. It has more efficiency and sustainability. It is a portable type pattern. Next, please. Battery operated cutters not only afford reduce emissions and noise level. That is a very important part in residential and sensitive environmental settings. So the effectiveness is too good and cost effective as well as grasses are found to survive in the arid conditions. So it has to be removed fertilizer both and remove the grasses. Next, please. The necessary operated cluster must produce number of unpleasant effects on human as well as environment. Running and maintenance cost of traditional cluster is high, so we have to reduce the cost as well as easy operation. It is very good for the small and marginal farmers. So we have designed the machine as well as fabricated for the small and marginal farmers. It is a portable and pollution-free machine and zero fuel operated equipment. Next, please. In agriculture, nursery, in household, growing grass is a commonly found problem here. They are not tedious job, lot of human efforts, time also taking, removal of grass need to be mechanized. So the machine designed on the basis of this. That is the study. Next, please. These are the material methods. Basically, these are the main components of the machine: crank, motor, blade, battery, high adjustment mechanism, handle, switch, wiring, blade. Next, please. So this is a frame, hollow iron pipe is made to make the body frame structure. It contains basically two pipes. One is the lower pipe, length is 77.2 centimeter, diameter is 2.4 centimeter. Second upper pipe, length is 92.4 centimeter, diameter 3 centimeter around. Pipe of thickness of 0.5 centimeter, length is 12.9 centimeter, width of 3.5 centimeters. It also has a handle of length of 40 centimeter and 2.45 centimeter diameter.
So it won't go on detail.
Okay. Okay. Next, please. The motor is 12 watt. DC motor is available. The RPM is 1400 RPM. Next, please. This is the blade. Basically, the vertical rotating shaft is also the blade attached to this shaft, and the blade 12 volt 8 ampere hour battery is available, and the battery is basically attached to this battery operated plus cutter, and the battery is kept on a bag which is kept outside, which is kept very back of the human being. Next please. This is a high adjustable mechanism for comfortable working to every 5% we decide to give that high adjustable mechanism. We can increase and increase the length of the cutter frame by only the tightening the nut and bolt in the hole providing on the frame. Next please. This is a very also provided so that person can easily move and cut the grasses, zebras with the help of this. The handle of and length is 14 cm and diameter is 1.4 cm. Next please. The switch is also provided, wire is also provided. Next please. Next please. Next please. This is the brake cover. Basically, neck is also provided, having the size of 4 and 4 cm mesh iron set for the protection point of view, the human as well as the cutting of the blade. Next please. This is the specification of the machine. Single row weight 10 kg, total weight of the machine length, width of the cutter, size of the blade 25.5 cm. Number of person needed to operate the machine 1. The operating speed is 1 to 2 km/h. Next please. Component of the machine specification. These are the frame, blade, motor, platform, motor, handle, battery, platform. Next please. This is the fabrication of machine in the workshop. Machine was fabricated in the workshop. Next please. These are the fabrication processes involved in the machine. Next please. This is the machine was tested in the field and nearby area of buildings, academic building, as well as
If
buildings.
small video is there, then you can
Okay.
otherwise it is fine.
Okay, next please. Yeah, small video is there also, it's operating the machine. This is the brush cutter. The total basically brush cutter compared with your black cutter. Brush cutter, it has a number of components, blade, motor, blade, lower frame, etc. Next please. This is the automated design of the dimension of the brush cutter. The length of the machine basically lower length as well as upper length. Lower length 77.2 cm, upper length 92 cm. Next please. This is the automated design of the motor platform. Next please. The related discussion and different length of the blade were used and found the 25.5 cm suitable length and the field efficiency was around 74.4%. Next please. And the field efficiency with the blade as the basically graphical representation of the machine. Next please. This is the cutting efficiency and found the cutting efficiency was 95.5% with a speed of operation of 1 to 2 km/h. Next please. The effect of speed on efficiency, when you increase the speed, then the efficiency will increase, then after the efficiency will decrease, you see the speed of operation meter per second. Next please. Field data sheet of this brush cutter. Next please. This is the test observations of the machine and different land conditions. And this is cost analysis, manual working, labor, steam, mode of operation by air, the cost of pressure 6400, the battery operated, the cost comes around 1000. It is a saving of this. The labor cost we computed for 400 rupees per day. The total cost of saving of the cutting per factor is rupees 5400 around. Next please. The statistical brush cutter. Cutting efficiency 95.5. Width is the 25.5 cm. Speed of operation 1 to 2 km/h. Actual efficiency is 74.4% and our required is 100 km/h. Next please. This is the cost of brush cutter. When cost comes around, remove this from talking to sections, and the cost comes around 1600 rupees. Total cost of this. This is summary and conclusion. Field efficiency of brush cutter is increase in the speed up to certain level. Afterward, it might decrease. The average field efficiency of brush cutter is 74.1%, whereas the petrol brush cutter it was 65%. And you see the efficiency of the battery operated brush cutter is cutting efficiency. Actually, you can say it has increased by 9.4%, and that is better than the you can say the Indian operated brush cutter. Next please. The human fatigue is completely less, and there are increase in the productivity. It can be drawn by the both men as well as women by just adjusting the height. Spare part can be replaced with the use of the separate tool, so it is highly flexible as well as easy to operation with minimal skill level, produce product sizes reasonably economical for even medium size with farmer. So handle can be made adjustable to suit the operator's height. Next please. The cutting with the machine reduce human treasury, reduce labor, fuel and reduce time. With high RPM, sharp blade has to cut the brush easily. Cutting efficiency of cutter is around 95.5%. It is very cost effective for complete cost of machine is about 700 rupees, 1700 rupees. And it comes other expenses in operating are considered. Then it cost is about 2000 rupees. It is a very lightweight and about 10 kg for a very easy to operate. Thank you very much for providing me the valuable time. Thank you very much.
Thank you, Dr. Maheshwari. Sir.
What is the duration for which you operated?
We operated, sir, around about 3 days.
What is the duration for?
We actually operated full charge battery and operated 3 to 4 hours. But we 3-4 hours continuously operated the machine in the field conditions. And we not only a single day.
Thing is, you have mentioned the cutting efficiency reduced after some time. So that is the reason. Your current and voltage supply to
The battery is also good actually that's what we
3 to 4 hours, whatever you said, it is verified.
yeah.
And the other thing is how do you decide the pipe size where you are mounting the blades?
On the basis of pipe size we decided already we decided the pipe size on the basis of blade can be attached and motor available in the market. So main important part available motor Chinese motor.
You take into consideration the torque required.
Yeah.
What is the torque?
Torque is also important part of the related to
That is
this.
the most important part.
Yeah.
Because here cutting is done the impact.
Yeah.
So how much impact force you are applying?
The speed is also very high also. Speed, so there is two important parts. Impact as well as speed when the rotation is very high. Naturally the glass can be cut so fastly.
Because the minimum variation of speed to carry out cutting.
Yeah.
That has to maintain.
Yeah.
So when you try to maintain that only because of minimum torque required.
Yeah.
So that is measured according to design pipeline.
Yeah.
आप इसको नोट कर लीजिए अच्छा सर सर हाँ
Thank you.
Dr. Sir, your work is good. I know you have done this work in Itawa, and Itawa is very difficult place where even doing work is very difficult. I think this machine is first machine for any engineer.
We have designed 3 more machines regarding this 4-day type. This is battery operated. All of them.
Right. Means you have.
We have designed.
So you have workshop facility or not?
Yeah, person battery is available, sir, but human beings are not humans. Actually, techniques are not available. That is also important part there.
You can say this is very simple device, but for that place he is alone, and for working that place is difficult. I know. Once I visited that place. Any more questions?
The cost.
It costs around 700 rupees. 1700.
नहीं इतना तो कम नहीं होता 1700 रुपीस
Yeah.
तो कॉस्ट ऑफ मोटर और
No, yes, 1700 rupees.
बहुत कम है बहुत अच्छा है
Yeah.
Sir,
Yeah.
probably you know that Honda is the oldest one in India that is engine operated, petrol operated.
Yeah.
But you might know that it is generally comes 1.5 HP to 2.5 HP and 40 cc to 50 cc engine.
Yeah.
But yours only 25 watt. So my sir question is that you just justify whether Honda, the Japanese people are over designed, yours is over designed.
Yeah, actually that machine was engine operated and the cost was very high, sir, correspondingly. Here the cost is very high.
I am not
Yeah.
the cost.
Yeah.
Because I am talking about the power in terms. Like
Power in terms.
Raymond sir said power in terms.
Mm.
Yours only 25 watt.
Yeah.
But Honda people, it is, in market you will get only 1.25 HP to 2.5 HP. That is 40 cc to 50 cc, 52 cc engine. So,
Yeah,
25 compared 1.5.
yeah, actually here the small size, basically battery we have used 12 volt battery, 25
very specific also. It may work for some community, but may not work for other community. Because tag requirement is very, very important. If you are taking 161 by 30 power, then it is not suitable for all. But it may be for some community it may be useful. Thank you, Doctor.
Thank you very much, sir, for providing thank you very much. Thank you.
Anybody who is present for next presentation on by some yes. What is your number? 6 number is there. So 4 and 5, 4 that is Dr. B होंगे. Dr. KB Lohakare? No. So then Dr. B said development and evaluation of smart tractor operated sugar cane setting transplanter.
Respected chairpersons, reporters, and then Director C. Gopal. Good afternoon. So this is my presentation on development and evaluation of small tractor operators working seeding planter. So it's a joint development between ICRC Regional Station and ICRSB Coimbatore. So we have developed a couple of equipments for sugarcane mechanization with SB Coimbatore and SB. So this is a sugarcane. Usually sugarcane is planted by cells, but alternate technology has been developed by SBI Coimbatore for using the sugarcane seedlings by having the bud chips. So by scooping up or cutting the chip portion, then we can developing the seedlings from out of that buds. So this is a alternate technology for planting in sugarcane. So that is picking up well. So for that we have developed a couple of equipment for making buds or single buds also we have developed already. That was commercialized by the institute. So this is the advantage of sugarcane seedling. So only usually the sugarcane sets is more than 2 tons. 1.5 to 2 tons per hectare is seed can is required. But only this by using this sugarcane single buds we can have only 500 to 600 kg per hectare. This seed rate is reducing also next place. So this is a technology, single bud technology, the different thing. So single bud or bud chip or anyone can develop seedlings next one. So these are a couple of equipment already we have developed for bud chip technology. Next one. So this is a planting method by the sugarcane seedlings or seedlings. Either 3 feet, 4 feet or 5 feet. Now 5 feet planting also is going on. Also plant to plant spacing you can have 45 cm, 60 cm. So this is a single planting by the distance next one. So this is a bud chip seedling production by using the bud chips or single buds in progress. Next. So this is the seedling production. Next one please. So this is the LT seedlings, 30 to 35 days seedlings that is used for transplanting. So now the manual transplanting and mechanical transplanting is going on. So next one. This is a traditional method. So they are marking the distance by some marker and then making a hole and then planting by manually. So each one also fertilizer application. Next one. The next one please. So this already we have developed 2-row tractor operator seedling transplanter. So that was commercialized by our institute. So 3 manufacturers already manufacturing and supplying this equipment. I think we have sold more than 60 units of this sugarcane seedling transplanters. So it is included in the Government of India subsidy system. So Next, so based on this experience, so for making this successful in small farms, we have developed a small tractor operator. Sailing tractor and next one. So this is a CAD diagram of a small tractor operator. So we have the tractor operator is a two row. Now we have designed as a single row. So for suitable for small tractors. So small farms we can use a small tractor. So this is a single row. So here we can make a row to adjustment easily. We can also plan to run spacing. Plan to run spacing 30 centimeters, 40 centimeters. We can alter by adding the adjusting mechanism. So these are the different components of sealing transponder, main frame, then thorough opener, the ridger, and also the fertilizer box, the industry mechanism, everything is there. So this is the operational view of the socket sealing transponder. We can operate with any small tractor between 80 to 24 HP tractor. This is the attachment with fertilizer application also. We can apply the fertilizer on the spot along with the socket sealings. This is the spot application we can make it by the machine next one. So operational view of this socket sealing and transplanter. So we have compared this socket sealing tractor operator and also manual planting also. We have done comparative trial socket reading into field. Next one. So this is the field performance data. So we have done two places. One is socket reading into Coimbatore, another one is towards Manali and towards near Europe. So this is the area forward speed is 2 km per hour, depth of planting 40 millimeters, and actual field capacity between 0.2 to 0.2 hectare per hour. Then field efficiency is 70 to 75%. Then cost saving is 75% compared to manual planting. The cost of operation is 2,450 per hectare. So the conclusion is suitable for small farms, between 1 to 2 hectare farms. So the farmers are having the small tractors, so this can be adaptable. Then actual field capacity is 0.2 hectare per hour. Cost saving is 78%. Thank you.
Thank you, Dr. Sanjay Kumar. And cost of operation, this tractor operation cost or only machine cost operation?
Total cost.
It is open for discussion. One or two very quick questions you can get on this presentation.
What is the cost of equipment?
It is 1.5 lakhs.
क्यों आप सुन नहीं रहे क्या? If you are not hearing, then there is no question there. If you are understanding each and every line, then it is no problem. But
Manual planning.
thank you, Narsar, because it is an excellent presentation and excellent technology also because the number exported also in this machine and very good. But we cannot consider you for award because you are executive member. ठीक है सर? So next
the presentation of chairs, like the awards.
Next, what is your 20? Prototype feasibility testing. Number कौन सा होते हैं? 18. Serial number 18. That is development of tractor operated sugarcane leaf retracer cum spreader. First introduce yourself and then you play.
Good afternoon, everyone. Myself, Dr. Sanjay Kumar, Assistant Professor, Component Machinery and Chemistry. Instead of Dr. Ali Rathod is not available because of election committee. So I am present here this topic. Yes. Title is Development of Tractor Operated Sugarcane Detection Stator. This equipment designed in the process of ASF methane. This objective of this project is development of tractor operated sugarcane detection stator, and second objective is performance of this implement. This investigator is Dr. Akira. This implement designed under the guidance of Dr. K. Rashtriya sir, professor and principal investigator in ASF methane and behavior. Some design consideration of the design considerations is required of this machine. But the machine should be used for detaching and shading the leaves of standing in sugarcane crop. Some of the developed machine should be affordable for the last end user, and these machines may the design consideration, the strain, rigidity, vibration, noise level, and the easy of handling and safety of use of a user and easy effect maintenance. These are the considerations design considerations. This is the methodology of this design. Some formulas is used for calculating the power. Some power rating 1.78 HP is required for power of the detaching. Calculations of the weight velocity, some forces can be calculated, centrifugal tensions can be calculated by using this formula. Centrifugal stress, minimum tension. Solid shaft subject to twisting movement. This is the isometric view of evaporated sugarcane detection stator. Nice. This machine of the video target. This is the orthographic view. Next. This isometric and orthographic view of this implement. Yes. This is the 3D view of actual 3D view of this type of operated sugarcane detection stator. This is the frame, and four rotors are attached. This nylon wire is attached to this roller. One 3D operated machine. This is the core box and gear box. Right? This machine is attached behind the laptop. Each arrangement is there. Next. Overall dimensions of these machines. This is the economical requirement and functional requirement is required. Economical requirement, it should be row spacing is 4 feet, and functional requirement, this requirement of this prime wall is for 24 HP and above. Factor is required. Yes. So actually this prototype developed on this sugarcane detection stator. This is the tractor operated machines actually working in the field of sugarcane. See this photograph before operation and after operation. The leaves can be detached and shreds. Some test code is used. BIS test code is used. This is the field performance test carried out. The total duration taken of this test is 42 hours, and some different places in Kolhapur district, Karvikas is select for this testing, field performance testing of this sugarcane detection. tests carried out with the field moisture content level is up to 10 to 11.5% is moisture content, and the forward speed is 2.9 to 2.35 kilometer per hour required. The total area covered, average area covered is 0.31 hectare per hour is required, and this machine after its use of this sugarcane in percent of 15.07 percentage of crash size reduction is reduction of this using of these machines, and operating cost of this machine is required 1,800 rupees per hectare. Cost is required for this operating cost. This is the overall performance of this sugarcane detection from Stader. The net duration of this test is up to 42 hours, and then field efficiency is average field efficiency is also 82%, and the next saving.
Okay, sir, it is good. What is next? Is it commercialized or?
This machine is commercialized. Our institute, DKU and manufacturers collaborate.
You have license this.
License for 5 years license agreement.
It is.
Yes.
And any patent application on this? Because same machine, I think it is developed in Coimbatore also. Coimbatore also.
So, sir, after that, there is some modification. Some modification is done by Coimbatore. This is our first innovation.
Modification of this machine.
Yes. By Coimbatore.
Okay. Thank you, Dr. Sir. Thank you. ताले को बजा दी सबको।
You mentioned one standard which was used for testing of this machine. What was that standard? Is it for deep pressure?
Deep pressure or some other
Different for else. So there is no standard.
I think standard is not made for the.
You just referred some other standards for taking the performance of that. Like sugarcane harvester.
Harvester recently we developed the standard.
Yeah. So recently, last 2-3 years, ISAR has tested the Shaktiman.
Then next, anybody present? Yes, sir. What is your serial number? 40. 20. 40. 1. That is development of knee tractor operated multi-craft pneumatic planter.
Hello.
Yes, sir. टाइम बहुत कम है, खाना खाना हो तो आप जो है प्रोसेस प्रेजेंट करिए। मेरी लाइन लंबी रहेगी, खाना
Okay, sir. Respected Chairman, Co-Chairman, Rapporteurs, and other delegates, I am going to present the development of great multi-crop community planter. So here we just I highlight some points regarding introduction. As we know, so if you want precise sowing, then we have to go for pneumatic technology. So we use here pneumatic technology. And second thing is we want to make the machine which is operated by the wind. So one thing is pneumatic technology of sowing, and second thing is it should be operated by the next. It should be operated by the wind tractor. So for this we develop this machine. Yeah, this is the estimate view of the machine. So main thing is that it is the seed beating mechanism. That is the mobile technology we use. In that there is the word drum. Next. So this is So this is the drum, and on this drum we make the holes. But the problem is that holes is that during the suction we cannot get the proper during the vacuum or vacuuming process of this drum we cannot get the proper suction. So So we developed here nozzles. This on these holes we provided the nozzles, and on these nozzles we make the hole of 1 mm with the rubber band, which is a hole shape, so that we can get the 100% picking of the seed or sticking of the seed on this drum. And then all things are same. We use air motor, means pump, vacuum pump, which is operated by the battery of the tractor. We use a brush, nylon brush to disconnect these seeds in the seed tubes. And the power for rotating the drum we take from the ground beam. Rest the particular mechanism is same as usual. We use another cameras. So this is the novel technology we developed, and for this we get next. We are applying for the patent, and we got the patent in 2024. We applied in 2020, and we got the patent for this technology. And now we are trying to give the license to the lecture for this next. So there is a performance of the machine. I can show the video of this so that you can show the video.
Directly go to the video.
Yeah. So this is the video of the machine. So we operated this machine for 1 to 3 kilometers per speed. So we can get some crops we get the good results for 2 kilometers per hour. Some sheets we get the good result for 3 kilometers per hour. Only at disadvantage is the speed.
Thank you for big hand for the patent. Good research. और अप्लाई जल्दी से करिए because the benefits will get the farmers. So small query, any small query regarding this?
We tested it was 7 crops and
समझ गया CIE ने भी बनाया है लेकिन CIE ने पेटेंट नहीं किया.
And this is made of big tractors. So we made of small tractors and there is the
we got the
cost of the machine.
कोई क्वेश्चन है? If not, then let's take the
one more advantage of this machine is we are not required to develop entire machine. The only system is required, and system cost is only about 4,000. So any farmer means we develop the system, we can install this system on any planter, which is multi-crop planter. So that whatever the farmers available with this planter, we can just install it on. It is just so that the entire part of the machine is also not required.
So that kit you are supplying or
Then we will make this kit. If farmer want to give the attachment to his existing machine, then we supply the kit. If farmer want old machine, then he can take the old machine. Like this we want to commercialize.
Clear, sir. Next.
Okay, thank you.
Who is next presenter?
Only online.
Online. फटाफट को online who is online?
Dr. Vivek from the
कौन सा नंबर कौन सा है?
03.
03.
So 25.
25. ठीक है. Development of vegetable transplanter for small and marginal farmers.
Dr. Vivek.
Dr. Vivek, first unmute yourself.
Please sir, your presentation.
Next, who is next? मनीष कुमार सीआईई कौन सा टीका है? मनीष कुमार.
Vivek, you please unmute your presentation.
Unmute option भेजो. option भेजो पहले unmute करो. option भेजो.
No, we are not hearing, yes.
कुछ अनम्यूट तो हुआ, अब बोलिए।
हाँ
डॉक्टर विवेक, यू अनम्यूट अगेन। फिर आप म्यूट हो गए। जस्ट यू अनम्यूट योरसेल्फ एंड देन स्पीक।
अनम्यूट ऑन कर दो, अनम्यूट ऑन कर दो, वो आपको बताएगा। म्यूट ऑन हो गया हो।
अपने सिस्टम में स्पीकर दिखा रहा है।
Please add your presentation. Please add your presentation and unmute.
हाँ, गया। रामायण कैसे हो सका? हाँ, यही है।
आपका माइक ठीक है क्या? उसमें प्रॉपर्ली करना है उसमें। उसका मोबाइल यहाँ पे माइक में रख के
मोबाइल को कनेक्ट करिए।
What's the presentation?
different ideas.
ये तो है
Other than
इसमें नहीं है।
there are two people. Instead of Vivek, somebody has wrote it.
No. What else to be? Yeah. Now it's connect. Now it's coming. Please unmute and speak.
Otherwise you can use your phone.
Otherwise you
Put it on the speaker.
हाँ, बस उसको लगा दीजिए।
you got the link and then speak.
सर फुल स्क्रीन
Make it full screen mode. Okay, Lord, wait. Please complete within 2 to 3 minutes. Wait.
उसको
Wait.
डिफॉल्ट
Start your presentation.
माइक को डिफॉल्ट करो। सर एक बार बात बोलिए।
Hello. Wait.
Do you have a link of this meeting? Link is online. You can connect to that and
This may not go ahead.
Yes,
Go ahead.
we are now working. Increase volume.
Use the camera.
Dr. Vivek, are you using two systems? If you are using two systems, please close one, stop one and use only one because echo is coming. You mute one system and you use only one. Why echo is coming?
ये महेश चौधरी यार महेश बाबू को म्यूट करना।
So even though the 720 transplanters are there, we just see the series.
Dr. Vivek, you leave the introductory part, you come directly to vegetable transplanter, what you have developed.
Okay, so.
Yes.
Yes, sir, yes.
Sorry for interrupting.
Okay, sir, okay. Actually, we developed a digital transplanter for small and large farmers. It consists of 4-bar mechanism. And this is a CAD diagram of digital transplanter for single row. It consists of main frame and tray counter, 4-bar heating finger. And this is developed the view of digital transplanter. This is a single row digital transplanter. Here, three mechanisms. It consists of three mechanisms. One is for lateral movement of the protray, and then downward motion of the protray, and another one more mechanism here, which we develop, and to pick the seedlings from the protray one by one. And this is a lateral movement of the protray mechanism. And here another one more mechanism added here, and furrow closer is there, and here is a furrow opener is there. So furrow opener is open the furrow and meter the seedlings by mechanically, and everything it is controlled by the ground wheel. All the power is taken from the ground wheel through the chain and sprocket. So the calculations are done here. The chain and sprocket here provided, and this is the result we obtained in the soil bin. Success rate of transplanting was averagely we got 86%, and missing of seedlings was 5.29%, and damage seedling percentage was 4%.
Thank you, Dr. Vivek. We got your message, and thank you. Sorry, because management of this university is coming again and again because we are running late. What is the next? Have you commercialized this machine or any patent or any paper you have published on this?
The patent, sir. Design patent we applied, sir.
You applied?
Yes, sir, we applied.
Any paper you published?
Sir, but not yet received, sir. We applied for design patent, sir.
Okay. Thank you, Rasa. Thank you. Actually,
If any video is there,
if any video
is there, you please play.
you can play.
Yes, sir, but video at present I don't have, sir.
Okay.
Just-
No problem. We come to next presentation.
Yes.
One more presentation is there, and
Please answer.
food has started 1 hour. it is running, and it is going to finish. One more presentation is there.
Yes.
Thank you, sir.
How long will you take the next session?
Yes, we can take. Right. We can take the next. ठीक है ना?
Please,
Okay.
You are there in next session, na?
Yes.
So you take, because I have to leave.
Oh.
Yeah. So then you.
Okay. Anyhow, we will continue this session after lunch break. When we can.
2:30.
2:30 we will sharply start. So initially we will start with the same session, and then we will continue with the other proceedings. So thank you very much. Thank you for all the participants who are there, and I really sir, I really thank our chairman who could able to give a very positive remarks on all the experiments and the deliberations. Anyhow, we are really happy to be here, sir, and we really congratulate for having honored this particular session as the chairman of this session, and thank you very much.
Thank you, sir. Thank you all. Again, you can take the presentation of Mr. Dr. Vivek.
Small moment of chairman.
Thank you, sir.
Thank you.
Vehicles are available in front of college building.
After lunch, 2:30 we can start.
Please assemble here at